Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called He Found He Could See Round Corners by Mello Robinson. That would actually be a very cool superpower, I guess. But I'm guessing it's because we have corners around here. Um, Anyways, here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Also, digits in cages do not repeat and sum to the given total. So, for example, these 3 digits must add up to 15, these 5 digits must add up to 22, these 5 must add up to 28, these are add up to 21, etc., etc. So as an example, we could use something along the lines of this could be 2, 6, and 7. Because those 3 digits add up to 15, that satisfies the cage, and there are no repeats that satisfies the cage. Also, the other rule we have in this puzzle is adjacent digits on a green line have a difference of at least 5. So these are German whisper lines, and for example, if this was a 3, this would have to be an 8 or a 9 because the only digits that have a difference of 5 or more from 3 is 8 and 9 specifically. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so first things first, we know that if you have 3 digits adding up to 7 and 3 digits adding up to 23, and they're all unique, the only possible combinations for the 7 is 1, 2, and 4. The only possible combination for the 23 is 6, 8, and 9. So the remaining digits have to be 3, 5, and 7. For digits adding up to 8, 3 digits adding up to 8, you have 1, 2, 5, and 1, 3, 4. But one of them has to be 1. For the 22, it's similar in that it's either 5, 8, 9 or 6, 7, 9. But either way, the 9 has to be in one of those cells. And it's very similar, actually, sort of, how do you say it? It's rotationally asymmetrical. Actually, it's not even rotationally symmetrical. It's basically just symmetrical around the negative axis here, right? And it's kind of similar in a sense this way, in that this is the 23 essentially is the high version of the 7, the 22 is the high version of the 8, and the 21 is the high version of the 9. Because if you think about it, right, you take the 2 greatest biggest numbers that you can in Sudoku, which is 8 and 9, and you take the 4th highest one, which is 6, 8, 9. And if you take the 2 lowest digits in Sudoku, which is 1 and 2, and then you take the 4th lowest one, which is 1, 2, and 4, right? And that adds up to 7 and 23, and then you subtract 1 from each of those, you get, or you subtract and add 1, respectively, for each of those. So therefore, it's a similar thing, and then you subtract 1 and add 1 for each of those. Oh, okay. Well, also another thing is this is 15. This adds up to 21. So the total box would add up to 45. So 45 minus 21 minus 15 is specifically 9, right? 45 minus 21, 21 plus 15 is 36. So 45 minus 36 is 9. So these 3 cells must add up to 9. And specifically, so this can't be 9 here. It can't be 7, 8, or 9. It's 5 or 6, which must be with 1 or 2. 1 and 2 or 1 and 3. Either way, the 1 has to be one of these ones. And this is 5 or 6, so therefore this can't be 5, 6 here. It has to be 7 or 8 or 9. So one of these is 9. We're not sure which. Therefore, this can't be 9 since one of these is 9. It's 6 or 8 here. So the 9's either here or here, or here or here. So either way, this must be 9. So this must be a very similar thing in box 9, right? This adds up to 9, this adds up to 18. That's 27. Uh, hmm. 45 minus 27, though, is 18, so that's not quite the same. Oh, we do know that... Okay. So, what... These are separate... This entire cage is a German whisper line. If you had a high digit here, the most that this cage could add up to would be... So this would be 9 if this was the highest high, and then 3 and 4 if those are the highest low digits you could have. And they have to be low digits because you'll always alternate between a low and a high on a German whisper line, right? So therefore, right, because if you have a 6 through 9, subtract 5 or more from the highest digit, which is 9. That means you have to have next to it a 4 or below next to a 6 through 9. And then vice versa. If you take a 1 through 4, take the lowest digit, add 5 or more to it, you get 6 or above. So every digit next to a 1 through 4 has to be 6 or above. Every digit from next to 6 through 9 has to be 4 or below. So always alternate between lows and highs. So if you take the highest high here, that would be 9, and then the highest lows next to it would be 3 and 4, but that only adds up to 16, which is less than the actual cage value. So this can never be high. This is always low, and it has to be next to 2 highs. Well, you can't have a 4 here. You could have a 3. So this is 1, 2, or 3 here. If this is 1, this is 8, 9. Oh, I guess you do kind of have something similar. If this is 1, this is 8, 9. If it's 2, it's 7, 9. If it's 3, it can be 6, 9, or 7, 8. We're not sure which. But if you take a 19, say you have a 9 here, you know anytime you have 3 digits, 3 unique digits adding up to 9, 2 of those have to be from 1, 2, or 3, right? Because if you say you have only 1, you try to have the lowest one would be 1, 4, and 5, right? Without having 2 from 1, 2, or 3. But that adds up to 10. So that's not possible to get only 1 from 1, 2, or 3 in this 9 cage. We know this is 1, 2, or 3. This must contain 2 digits from 1, 2, or 3, right? It's either 1, 2, 6, 1, 3, 5, or 2, 3, 4, all of which contain 1, 2, or 3. Therefore, there is no 1, 2, or 3 in the rest of the box. So this cannot be 1, 2, or 3. It has to be 4 or 5. Which means this is also... It's 1. One of these is 1. So if that's 1, that can't be 1. If this is 1, it still can't be 1. So this is not 1. So therefore, 1 could be here, and 1 could be here too. Okay, and so this... must contain 2 out of 1, 2, or 3. This cannot be 1, 2, or 3, so it's 4 through 9. And this is 4 through 9, but we're not sure what those are. Let's see. What else could we do? Can this ever be high, low, high, low, high? I don't think so, right? Because then these 3 would have to be high digits all next to each other. And the lowest amount you can have there is 6, 7, and 8. And that's 21 already. And then you have 2 other digits, right? Because remember, these have to be unique. So you can't have 6, 7, 6. If you try to have 6, 7, 8 as the minimum, you also have to have 1 and 2, which is already 24, which means you're never going to get to 22. So this has to be low, this has to be low, this has to be low, which makes these high. What's the minimum here? Well, the highs have to be, they see 2 unique digits from each on the German whisper line. So they have to be 7, 8, or 9. So this is at minimum 7 and 8. Since this is at minimum 7 and 8, that means this has to have 1, 2, and 4 here. This sees 2 unique digits on a German whisper line, so this is 1, 2, or 3. If this is 7 and 8, one thing it cannot be is 8 and 9. If it's 8 and 9, that's 17, and then you have 3 unique digits trying to add up to 5, which is impossible, because the minimum is 1, 2, and 3, which adds up to 6. So this is either 7, 8, or it's 7, 9. If you have 7, 8, the problem is 4 can never be next to 7 or 8 on a German whisper line. So it can never be 7 and 8 because that would require this to be 1, 2, 4, adding up to 7, with the 15 adding up to 22 total. But then the problem is the 4 can't actually be next to 7 or 8 on a German whisper line because it's not 5 away. So this has to be then 7 and 9. So this is 7 and 9, which means we have 1, 2, and 3 all next to it. Right? So this is 16. This adds up to 6. So that's fine. This cannot be 1 because one of these is a 1, right? Either this is 1, which would make that not a 1, which makes that a 1, or this is a 1, which means that can't be 1, but that would have to be 1. Also, we have a 1, 2, 3, 4 quadruple in column 6, which eliminates 1, 2, 3, and 4 in the rest of the column. This cannot be 1, 2, 3, or 4. It has to be 5 or 7. This has to be, it could be 6 through 9 here. We're not sure which. Okay, what about this 28? Can you ever have 3 lows with 2 highs here? Well, 3 lows maximum is 2, 3, and 4. So that's 9. And then these 2 digits would have to add up to 19. So that's not possible. So this has to be a high. These are lows. And these are highs. Well, again, these 2 digits see 2 unique digits on a German whisper line, so they both have to be 1, 2, or 3. This has to be 7, 8, or 9. What's the maximum value this could be? So again, similarly to this cage, the maximum value here is 2 and 3. Well, if this is 2 and 3, the problem is that adds up to 5, which means there has to be a 6, 8, and 9 in the rest of the cage. But 6 cannot be next to 2 or 3 on a German whisper line because it's 4 or less away from 2 or 3. So it cannot be 2 and 3. It has to be 1 and 3. If it tried to do 1 and 2, the rest of the 3 digits would add up to 25, which is not possible for 3 unique digits, right? You can't have 7, 8, or 9. And you can't have repeats in the cages again. So it has to be specifically 1 and 3, and these are 7, 8, and 9. We now have, similarly, a 7, 8, and 9 quadruplet in column 4, which eliminates 7, 8, and 9 the rest of the column. This can't be 7. Interestingly enough, though, okay, yeah, we have something similar here. In box 9, or actually, let's say column 8, there's already 2, 1, 2, or 3s in that column. And actually, we know one of them's 1, 2, one of them is specifically 1, because this can't be 1. Because of that, we know there's 2 1, 2, or 3s in the 9 cage. Well, since there's 2 already in column 8, only one of them can be in column 9, right? Because we have 2 from 1, 2, or 3. We have a third from 1, 2, or 3. We cannot have both of them be in 1, 2, 3. So this has to be 2, 3, 4, 5, or 6. And this has to be 1, 2, or 3 here. Because otherwise there's no other possibilities for that, right? So similarly here, this 21 is either 489, 579, or 678, right? But it requires two digits that are from 7, 8, or 9, no matter what, right? 489, which requires 8, 9, 579, which requires 7 and 9, and 678 requires 7 and 8. So therefore, this is similar in that this has to be 4 through 9, and this has to be a 7, 8, or 9, because there's no other possibility, because one of the 7, 8, or 9 has to be here. Therefore, this can't be 7, 8, or 9. It has to be 2 through 6. What else do we know about this? I think that's kind of it. Unfortunately, this doesn't tell us much. These are both highs. We have one high here. It could be two, actually, technically. This 15, it cannot be 4, 5, 6, obviously. It must contain 1 out of 7, 8, or 9. But we don't know where that is. And it can only contain 1 out of 7, 8, or 9. Cannot contain a 1. Okay. Right, so this rest of, where is the 4 then in this cage? Well, the 4 in column 6 has to be one of these two cells because we have a 1, 2, 3, 4 quadruplet in the column, so the rest of the column cannot contain 4, and it has to be one of these two because these can't both be 4. So this can't be a 4 here. Oops. Not a 1. It could not be a 4. And similarly, the 6 in column 4 has to be one of those two, so this can't be a 6. Okay. Okay. What else do we know about this? So again, this has to be 1 through 5. This is 1 through 5. This is 1 through 5, and this is 1 through 5. The rest of column 6 is 5 through 9. Okay, that doesn't help us much. Can remove the corners from here because, well, excuse me. Still might be helpful. Oh, this can't be 9 here, which means one of these two is a 9, so neither of these can be a 9. Okay, so what are the what did I color that? What are the possibilities for this cage? Um, okay, oh, this is interesting. This could be 1, 8, 9 as a possibility. So if this is 1, 8, and 9, this becomes 2, 3, 4. This is 5, and this has to be 6 and 7. If this is 2, this is 7, 9. This is 1, 3, 5. This is 4, and this becomes 6, 8. If this is 3, okay, so it can't be 6 and 9. Actually, it can't even be 7 and 8. This can never be 3, 6, 9, or 3, 7, 8. Okay, well, that's actually very important. So this can't be 3, 6, 9, because again, you would have the 6 next to the 3, which is not 5 away from 3. And then 3, 7, 8, you have a 7 next to the 3, which is again not 5 away from 3. So this has to be specifically 1, 1, 8, 9, or 2, 7, 9, which means this has to be 3 in one of these cells. Well, we know 3. Right, so 3 has to be one of these cells, so it's either 1, 3, 5 or 2, 3, 4. 3 has to be one of these two cells because it's 1 and 3, so that means 3 has to be, one of them has to be in row 7 or row 8. And in this cage, it also has to be in row 7 and row 8, which means in the rest of row 7 and row 8, you cannot have a 3. So these cannot be 3s here. Well, we now have a 1, 2, 4 triplet in we have a 1, 2, 4 triplet in column 6, which eliminates 1, 2, and 4 in the rest of the column. This cannot be 2. This has to be a 3, which means this has to be a 9, because 9 is the only digit from 7 and 9 that could be next to a 3 on a German whisper line. Therefore, this is not 3, this is not 3, this is not 9, so this is 7, which means this can't be 7, and this can't be 7, and these can't be 1 or 2. So this specifically has to be 3 here, which means this can't be 3. So one of these is 3. We have a 1, 2 pair here. And a 9 has to be one of these two here. This cannot be 9 anymore. So 9 cannot be here, and 9 cannot be here, which forces this to be 7, 6, 6, 7, 8. Because 9 cannot be in this 21 cage. So this is 6, 7, 8 here, which means this is 7 or 8. This can't be 6, so it must be 5, which makes this 8 and 9 and 8 and 9. Again, these 6 digits add up to 36, so these 3 digits add up to 9, so therefore it must be 1 and 3 with 5, adding it to 9. And the remaining digits are 2, 4, and 9. 9 can't be here, 9 can't be here, 9 must be here, which makes this a 2, 4 pair here. Now we have an 8, 9, 8, 9 pair in row 4, which eliminates 8 and 9 in the rest of the row, so this must be a 6. This can't be 6 anymore, which forces another 8, 9, 8, 9 pair in column 4, which eliminates 8 and 9 in the rest of the column. Therefore, this must be a 7. This cannot be a 3, because 3 cannot be next to 7 on a German whisper line. Therefore, this is a 1, which makes that a 3. These are both not 7. It's an 8, 9 pair here. This can't be 7, and this can't be 7. Well, 7 can't be any of these, and 7 can't be any of these. Therefore, this must be specifically 1, 8, and 9. So this is 1, 8, and 9 added together. That's up to 18. This can't be 1, so this is 2, which means this cannot be, it's 2, 3, and 4 here to add up to 9, which means this can't be a 4 because of the 3, 4 pair in the box. These can't be 8, because of the 8, 9 pair in the box. So this can't be 4, which makes that a 5. This has to then be 1 and 2. Well, this can't be 1. This can't be 2 because of this 2. So this is a 1, which makes that a 2. That makes this a 4. This 2 and 4 makes this a 1. This 1 and 4 makes that a 2 here. This can't be 7 either. These can't be 8 because of the 8, 9 pair in the column. And it can't be 7 here because this is a 7. So this must be a 6, which makes this a 7, which makes that an 8. That makes this a 9, which makes this an 8, which makes that a 9, which makes that an 8. 8 cannot be in any of these cells. 2 cannot be any of these cells. This can't be 5 either. This can't be 9 because of this 9. This can't be 5, 6, or 7. Therefore, it must be a 9 because of the 5, 6, 7 in the row. This can't be 9. These can't be 9. These can't be 3 here. Okay. This can't be 9 because of this 9, so this must be an 8, which makes this a 9. This can't be 9, so this must be 8, which makes that a 9. This can't be 8. Where is the 8 in column 6? It has to be here now. So this is an 8. We know 8 cannot be here, 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 or here because of the 8s in the surrounding boxes. Therefore, this must be an 8. 9s. We know 9 cannot be here, 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 or here in box 6. It has to be here. And we have 8 9s. We know where the last 9 has to be. It has to be here. What about 1s? 1s, this can't be 1, so this is 2, which makes that a 1. Therefore, this can't be 1. 2 is kind of limited. 7s. Interesting, okay. That doesn't help us much there. What are the remaining digits in column 2? Let's just do that. It's 1, 2, 3, 1, 2, 4, 5. This can't be 2, this can't be 1. This can't be 1 here, so this is 2, 4, 5. Well, we only have one place for 1 now. It has to be here, in column 2. Because none of these can be 1. So this has to be a 1 here. Similarly, what are the remaining digits in... this can't be 3 because of this 3, so this must be a 4, which makes this a 3. This 4 means this can't be 4, which makes that a 1. So this can't be 1, and this can't be 1. This has to be 6 or 7 here. That's fine. The remaining digits in column 8 are 5, 6, and 8. Well, this can't be 8 here, so this is 5 or 6. Oh, the 2 cannot be next to a 6 on a German whisper line, so this must be 8. And this has to be 5 or 6 here. So we have 8. Okay, so now we know, we have 8 8s now. We know where the last 8 has to be. It has to be here. So this is an 8. What about row 2? The remaining digits are 2, 4, 5, and 6. Well, this could be 4, 5, or 6. Cannot be 2 because of that 2. This could still be all of them. Okay, so that's still... Okay, what about row 3? We have 1, 2, 3, 4. This can't be 2 or 3, so this is 1 or 4. This can't be 1 or 2, so this is 3 or 4. Where is the 2 in row 3? It has to be here. So this is 2, which means this cannot be a 2. Does that help us anywhere? Not particularly. Okay. 5s were very limited. I think we got all the 8s and 9s. 7s were still pretty limited. 1s were still kind of limited. Oh no, this can't be 1. Therefore it must be a 3, which makes this a 1, which means this can't be 1, so this is 4. Which means this can't be 4, so this is a 3. Therefore, this 4 means none of these can be 4s. We have a 2, 5, 2, 5 pair in column 4 and in box 2, which eliminates 2 and 5 in the rest of the column here and the box here. So this can't be 5, which makes this a 6. This can't be 5 or 6, which makes that a 7. This can't be 5 here, so this must be a 3. This can't be 3 or 5, so this must be a 4. This can't be a 7 because of this 7, so this must be a 5, which makes this a 6. This 5 and 3 means this has to be a 7 here. This cannot be 6 here. This is 4, 5, or 6 as a possibility. We now need a space for 1. And we have 8 ones. We know the last one has to be here. This has to be specifically 3 or 5, but this can't be 3 because of this 3, so this is a 5, which makes that a 3. The last remaining digit is a 4 here, which means this can't be 4, so this is 2. That makes this a 4. This 2 means this has to be 5, which makes that a 2. This 5 means this has to be 4, which means this can't be 4. This can't be 4, and this can't be 4 because of the 4 in the column. Remaining digits in row 4 are 3, 4, and 7. This can't be 4, and this can't be 4 here, so the 4 has to be here. And these could be still 3 or 7 here. We have now 8 4s, which gives us where the last 4 has to be. It has to be here, so this is 4. The last digits here are in column 3 are 2, 6, and 7, but this can't be 2. Where's the 2 have to be? It has to be here. So this is 2. This has to be 6 or 7. This can't be 2 because of the 2 in the box. So this is 5, which makes this a 2. I think that's all the 2s now, actually. This is 6 or 7. The remaining digits in row 5 are 3, 5, and 6. This can't be 3 or 5, so it must be 6, which makes this a 5. This 6 also makes this a 7, which makes this a 6, which makes that a 7. This is just normal Sudoku now. We make that makes that a 6. This 7 also makes that a 6. This is 3 or 5. Cannot be 5, so this is 3, which makes that a 7, which makes that a 3. This 5 means this can't be 5, so this is 6, this is 5. This has to be a 5, and this must be a 7. And that's how you solve it. Yeah, pretty straightforward. I guess the tricky part was essentially figuring out what the cages could be, particularly this long cage here, mixed with the German whispers. Yeah, and also, yeah, figuring out this could not be a 3 here. That was particularly important. I should have caught that immediately, but I don't know why. I just was focusing on the cage aspect and not the German whisper line aspect there. Pretty cool. Pretty cool use of German whisper lines in the cages, which forced a certain way, forced certain restrictions, shall we say. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.